Okay, so now let's see this question. This question came in GATE 2015. Okay, and the question is, suppose U is a power set of set S. Okay, so U is what? U is basically the set of all the subsets of S. So S is what? 1, 2, 3, 4, 5, 6. Okay, so U is what? You will have empty set and all something like 1, 2 till 6, and then set of two elements 1, 2, 2, 3, like that. You understand what is power set, right? So you use that power set. Now they're saying that for any t belonging to U, let mod t denote the number of elements in t and t prime. Okay, denote the complement of t. So for any t prime means complement of t, and mod t means the number of elements in it. So it is the standard denotation, and this is also standard that t subtraction r is basically all the elements of t which are not in R. Okay, the set of all elements of t which are not in R. Okay, fairly standard. They have given 4 options and we have to see which of them is true for this particular scenario, where S is our set, this set 1, 2, 3, 4, 5, 6, and U is the power set. We are going to talk about that. Okay, so let's talk about the first element, first option A. So in that they are saying that for all x belonging to this power set, x is equal to the size of x is equal to the size of x complement. Now that on the face of it obviously looks wrong, and it is wrong essentially. See, if x is something like 1, 2, what is x prime? Tell me. Simply whatever elements are not there in this x but they're in x, so that will be simply 3, 4, 5, 6. Now how on the earth it can happen that in all cases they are saying that in all cases this and this are equal? You can clearly see what is the size of this 2, what is the size of this 4. So definitely this is directly wrong. What about the second one? They are saying that okay, so if it is the case that x, there exists x and there exists y in the power set, and if that is the case that size of x is 5 and size of y is also 5, and at the same time x intersection y is 5, it means that x intersection 5 y is 5, it means x and y have no elements in common, which means that x size is 5, y size is 5, and both are having 5 distinct elements. There is no sharing, so at least there should be 10 elements overall, but there are only 6 elements here, so that is definitely not possible, right? So I'm trying to say something like that if x is having 5 distinct elements, let's say 1, 2, 3, 4, 5, and you are saying that okay, y should also have 5 elements, so there has to be 5 elements, right? At the same time you are also saying that intersection is 5, it means all of these must be different from 1, 2, 3, 4, 5. Now we are only having only 6 elements, so 6, let's say 6 will be there. After that, what element you will keep here? You can only keep something out of 1, 2, 3, 4, 5, right? Now if anything comes, like 1 comes, then okay, now the intersection is not 5, but it is so definitely this is also wrong, this is also wrong, this is also wrong. Let's come to the statement 3. So in that they're saying that for all x and for all y belonging to this power set, if that is the case that size of x is 2 and size of y is 3, then and at the same time is it possible that x subtraction y is 5? Okay, so such a situation is possible, but they are saying that is it the case that for all x and for all y it is happening? So if x is something like this 1, 2, okay, and y is something like 1, 2, 3, okay, so in that case x minus y is what? Is 5, right? All the elements of x which are not in y, definitely it has none. So definitely it will be 5. But there can be some situation like this also, where your x is, let's say, 1 and 2, and y is 2 3 4. Okay, in that case when you calculate x minus y, then only 2 will be removed, but still 1 will be there. So 1 is there, which is not equal to 5, which means it is not empty set. So you cannot say that x minus y is always empty set if such a situation is there. So for all, if it would have been there exists x and there exists y, then it would have been correct, but for all x, for all y, definitely not the case. So this statement 3 is also wrong, and the final statement D in that case must be correct. However, it is correct, so D is obviously our answer, but we will try to again figure out that, verify that the statement 4th is correct or not. Okay, let's so these, all these 3 statements are correct. We are verifying statement D, which should be correct because it is the only option left. Let's check that. Okay, if somebody says you that T is an element of x minus y, what does it mean? What does it mean? It simply means that we are talking about that. Okay, so T belongs to x, there is no doubt about it, but at the same time it should also be that T does not belong to y, because if T belongs to y, then it would have been removed. It would not be part of x minus y. Whatever were common, they have been removed. So definitely T is not in y and it is in x. So this is the definition of this thing. Okay, so we have talked about, so we are trying to figure out this thing can happen only when these two sets are equal. For all x, for all y, these two sets are equal, then only. We are just trying to figure out, are these two sets equal? X minus y, we have figured out this thing. Let's talk about the second set, okay, which is y prime minus x prime, right? So let's say there is an element T which belongs to y prime minus x prime, and we'll try to figure out that whether this set is same as the upper one or not. Firstly, let's try to understand it simply by the definition of it. So what does it mean? Similarly as above, here we can write that, okay, T is definitely belonging to y prime, there is no doubt about it, but at the same time, as we did above, here also we have to say that T definitely does not belong to x prime. That is okay. Okay, okay. Now if T belongs to y prime, then we can say that T does not belong to y. Okay, then only it belongs to y prime. At the same time, if it does not belong to x prime, then where does it belong? It definitely belongs to x. Okay, so in the end we are getting here the same condition, T belongs to x and T does not belong to y. The situation is same which we got earlier, right? And therefore we can say that since T is such an element which belongs to x and what does not belong to y, for all elements which are belonging to this set and this set, the same condition is happening. It means basically these two sets are essentially same, equal. So these two are equivalent sets, and that's why the correct answer is D.